After you've looked at your data, maybe you want to see what of your variables correlate with each other. This is important because if you're going to build a model, you don't want to ask the same question twice. By that I mean, for example, if you put weight into your model, should you put in BMI as well? Because weight and BMI are related. And that can affect the model in a bad way because each of them can suck up the variance and making neither of them significant. So one way of doing this initially in a kind of broad processing way is doing a correlation matrix. A correlation is just when you do a regression, a simple regression between two variables. Okay. So read in our data. Then we have to do this little thing is we can only do a correlation with numerical data. So here I use this sapply and goes only use data that is numeric. Yeah. So that's only numbered data. Okay. And then this is it. That's it. Corr is a command and use a pairwise complete observations that takes care of NAs, and it creates this list. So let's start with X. X is correlated with ID, correlated with X is not correlated with age. Yeah. So what it does is for every single variable, it calculates, is it correlated? It calculates an OR value, not an OR squared value, an OR value. An OR squared value, as you remember, is between 0 and 1. OR value is between -1 and 1. The minus means you can tell, are they inversely correlated or positively correlated? Okay. So every single one of these values, so let's take that, for example, that's the correlation of height and X. Yeah. Not useful to know, but it's in there. Let's say, for example, height and height have a correlation of 1 because they're the same variable. Correlation of 1 means they 100% agree with each other. They do. Yeah. And so we get this large matrix of data that's, as I scroll through, you can get lost in. Yeah. So a child, for example, what does it correlate with? And so forth. It's hard to read. And that's why we introduced this library called Corrplot. So you have to load the library Corrplot. And then using Corrplot, you send in the correlation matrix. I'm going to use type upper. And what it does is it creates this nice little picture. Yeah. And what the picture is, it's showing that each of the variables as a function of the others. And what you can see is, you see where all these are blank, it means it's not a significant correlation. But what we do see here is weight and height are correlated. Yeah, because there's a dot there. Reaction time and age have a correlation. These X's all have a correlation, but that's a spurious correlation that we don't care about. That's just an order correlation. We also have age X and age Y are perfectly correlated because they should be. They're the same value. Yeah. We have, once again, weight and BMI. And what we need to be careful of is if we have two values that are similar like this, then we should not include both of them. We should only include one in the model. The justification which one to choose, that's a trial and error situation. There are other ways of representing it. So let's represent it in numerical fashion. Let's cluster it by numerical. And what it does is it clusters things together. So it clusters together weight and BMI. That's the first cluster. Then it clusters together distance, reaction time, and the two ages. But it's saying that these variables are quite related. Yeah. And of course, x.y, x.x, and di, they all agree very much, but we don't care about those variables. But what it also shows is that income doesn't correlate with anything. And maybe we shouldn't be including income in our model. Maybe we're interested in it for a different reason, but a good reason to exclude. Children and height seem to have some relationship, but also it has a relationship with BMI. It can't perfectly cluster them, so maybe it should be included up there. Yeah. And there are other ways of representing this to look at it graphically. This can be quite unwieldy, but at least better than looking at all those values. And seeing it here shows significance. It's important to know about how your parameters are related to each other before you once again start into your model. But there's a back and forth aspect to this. You might run your model, see something funny, go back to the correlation, rearrange things, make a composite variable maybe of things, and come back. But It's always about the back and forth between what you're learning from the model, what you're learning from your data, and going backwards and forwards.